A pleasant day to the young and enthusiastic learners. I'm Dr. Shobha Edward, Principal, Associate Professor and Head of the Department of Corporate Secretaryship, KCS Kasinada College of Arts and Science, here to give a presentation on regression. So a hearty welcome to today's presentation. Regression. It is a measure of the average relationship between two or more variables, and it provides a mechanism for predicting or forecasting the future. So when it comes to regression, there are two regression coefficients: the regression coefficient of x on y and the regression coefficient of y on x. So bxy is the regression coefficient of x on y. bxy is given by the formula r standard deviation of x by standard deviation of y, or it is sigma dx dy divided by sigma dy squared. The other coefficient of regression, which is y on x, that is byx, is equal to r standard deviation of y by standard deviation of x, or it is sigma dx dy divided by sigma dx squared. Now going on to the regression equations. Similarly, regression equations are two in number. We have the regression equation of x on y and the regression equation of y on x. Now going on to the regression equation of x on y. The regression equation of x on y is x minus x bar is equal to bxy into y minus y bar. The regression equation of y on x is given by y minus y bar is equal to bxy into x minus x bar. Now going on to the relationship between correlation and regression. If there is a perfect correlation, then the two regression lines will coincide. Higher the value of correlation, the regression lines will be closer. Lower the values of correlation, the regression lines will be wider. Where both regression lines intersect each other, we will get the mean values of x and y variables, that is x bar and y bar. Now the difference between correlation and regression based on the nature of relationship. Correlation analysis tests the closeness of the variables, where regression analysis measures both the nature and extent of financial relationship between the variables. Based on relationship, in correlation, the causal relationship between variables is studied, whereas in regression, the cause-effect relationship is studied. Mutual dependence of variables. In correlation, mutual dependence between variables is studied, whereas in regression, the dependence of one variable upon the other is studied. Spurious correlation. In correlation, there is a spurious correlation between two variables, but there is no such type of a relation in regression analysis. Going on to the mathematical treatment, correlation cannot be used for mathematical treatment, whereas regression can be used for further treatment. Origin and scale. Regression analysis is independent of change of origin, whereas correlation is both independent of change in origin and scale. Relative and absolute measures. Regression analysis is an absolute measure, whereas correlation analysis is a relative measure. Applicability. Correlation has very limited scope for application, but the scope of applicability of regression is very wide. Differentiation in variables. In correlation, both the variables are considered, but in regression, variables are differentiated as dependent and independent variables. Asymmetrical and symmetrical formation. Correlation is symmetrical information, but regression is asymmetrical information. Uses of regression analysis. It is used in predicting the unknown value. It is also used in establishing and estimating the nature of relationship between two variables. It is used in policy formulation in socio-economic fields. It is used in testing the laws and theories of social sciences as well as natural sciences. Going on to the limitations of regression, the following are the limitations. Assumptions of linear relationship, assumption of static condition, study of relationship in prescribed limits. So that goes with the limitations. Now the properties of the coefficient of correlation. The coefficient of correlation always lies between +1 and -1. The coefficient of correlation is independent of change of scale and origin of the variables x and y. The coefficient of correlation is the geometrical mean of two regression coefficients, that is, r is equal to root of bxy into byx. Going on to the properties of regression, both regression coefficients will have the same sign, either they will be both positive or both negative. The value of both regression coefficients cannot be greater than 1. The coefficient of correlation will have the same sign as that of the regression coefficients. Since bxy is equal to r standard deviation of x by standard deviation of y, we can find any one of the 4 values given the other 3 values. Like if r is given and standard deviation of x is given and the coefficient of regression is given, we can find the standard deviation of y, and so on. Regression coefficients are independent of change of origin but not of scale. The relationship between correlation coefficient and regression coefficient is as follows. R is equal to root of bxy into byx. Thank you and happy learning.